Okay, so homework, the regular homework is due, that is the regular book work is due on Monday. Your review work, which I'm going to do the same thing again this time. I'm going to make the book review optional, but the 2 review sheets are mandatory, and those will be turned in on your test day. And your test day is next Thursday. Next Thursday is your test day. So mark your calendars. Homework is due on Monday. Regular book homework, 2-1 to 2-5, due on Monday. Review work will be due on your test day, which is Thursday. Okay? So what we need to do right now is well, I got one still finishing up here. I'm going to go ahead and do a quick review of Descartes' rule of signs. Did we talk about this yesterday?
Yeah,
Just at the end, yeah. So I know we started the conversation, but we need to do another example or 2. And I want to point something out here that's really an important note to take. And that is, okay, so think of your PRRs. We all know how to find the PRRs, or we should know how to find the PRRs. Can I do my problems without finding the PRRs?
Yes.
Yes. What's the value of the PRRs? The possible rational roots. What's the value of doing it? If I can do the problem without it, why would I do it, Maya? Yeah, it's meant to be a tool. It's meant to be something helpful, right? Now, if your last coefficient is a number like 48, your last constant term is 48, PRRs don't help that much because there are like a zillion factors of 48. But if the last number is 13, then that would really help, right? Because there aren't many factors of it. So what I'm trying to say is the possible rational root rule is a tool to help you. You don't have to use it. Now, when Mrs. Ford says on the quiz, what are the possible rational roots? Obviously, you have to listen. But when you're going through and doing a problem, if you don't want to do it, don't do it. Just start guessing. Same thing is true of Descartes. This is meant to be a tool. It's meant to be a time saver. And we'll talk about some situations where it is helpful, and there are other times when it's not. I'm not going to do Descartes' rule of signs on every problem I do because sometimes it's just not helpful, but sometimes it is. So let's run through that process again. Look at another example. Let's say we have this problem right here. Okay, this is our polynomial function, and we want to know the nature of the solutions. And the nature of the solutions is the number of positive reals, the number of negative reals, and the number of imaginary solutions that this problem is going to have. You know that when you solve, if you set this thing equal to 0 and solve it, you know that some of the roots are going to be positive, some are going to be negative, and some are going to have eyes in them, potentially. So we want to know, okay, well, what have we got going on? We do know that we have 7 answers altogether, right? And they're going to be divided up somehow among these classifications. All right, so to figure out the number of positive real roots, what did we talk about yesterday? What do? We count the sign changes. So that would be, let's see, here's one, and here's one. So if you just look straight across the problem, looking at pluses and minuses, they switch term to term twice. Would you agree with that? So I write 2, and then here comes the tricky part, or 0. Remember, when you count your sign changes, no matter how many there are, once you you write that down, and then you decrease by 2's. Now, obviously, if there was only one sign change, there would be 1, because you can't decrease by 2. But if there were 5 sign changes, you would say 5, or 3, or 1. You just keep decreasing till you can't do it anymore. Now, negative real roots. We're going to count sign changes again, but before we count them, we want to pretend that x is a negative number. So if x is a negative number, this term right here would be positive or negative? Negative. This term would be positive. This term would be negative. Kids, if you square a negative, it's positive, and a positive times a negative is going to be negative, right? What about this one? If you put in a negative number, negative, and that, of course, is going to stay positive because it's 5. So how many sign changes do we have now? If we let x be a negative number, these are the signs in the problem. Looks like we have a change here, and here, and here. So that means what? 3 or 1. Now, to get the number of imaginaries, you just use your common sense. These are the number of reals. How many roots did you say we had all together? 7. All right, so we go through and look at all the combinations. We could have 2 of these and 3 of these. That would leave me with 2 imaginary. We could have none of these and 3 of these. That would leave me with 4 imaginary. I could have 2 of these and 1 of these. 4 again. And how about none in 1? 6. Now you're saying to yourself, that's an awful lot of ors, Mrs. Ford. A lot of ambiguity there. I'm not sure what's going on. Well, if I'm really charged with solving this, finding roots, and I figure out my PRRs and I start guessing, where am I going to start guessing? With negative numbers? Why would I start there? What would be my logic? I know for sure there is 1 of them. I know for sure there's a negative root out there somewhere. Right? May or may not end up being rational, but I know there's a negative 1.
Do you even need to do this for this problem since the factor is 5? That's only going to be 1 and 5.
Well, those will be the only possible rational roots. This is real now. Yeah, I'm talking about all of them. Yeah. But you're right. This would be a problem where the PRR thing would be really useful because when I'm guessing, I'm going to guess 1s and 5s. I'm saying direct yourself to the negative roots first, negative possibilities, because for sure we know there's 1 of them. Now, it may not be -1 or -5, but maybe we'll be able to determine that it's between -1 and -5 or something like that. Okay. All right, let's do another example. Make sure you can find these, fill these blanks in right here. Let's say we have 3x to the 10. Oh, one more quick comment before I move on to the next problem. See these numbers right here? These imaginary, the number of imaginaries? These will always be even numbers. Because remember what we talked about yesterday? What do we know about complex roots? They come in pairs. They come with a conjugate. So you're never going to have 1 imaginary root. You're never going to have 3 imaginary roots. You're either going to have 2 or 4. They come in pairs. So if you start doing this and these numbers come out odd, somewhere you have a mistake. These have to be even. Okay. All right, let's say this is our equation. And our job is to find out how many positive reals, how many negative reals, and how many imaginary roots we have. So we're going to use Descartes' rule of signs because that's how you determine the nature of the solutions. And this is what we mean by the nature of the solutions. Okay? So let's take a look at it. You know what to do. To find the number of positive real roots, you count the sign changes, and what do you notice? There aren't any. Now, that is a huge time saver, because what are you not going to do? You're not going to guess any positive numbers, right? There aren't any. So why would you waste your time guessing them? All right, what about negatives? Well, remember what we do. We put a negative number in for all the x's. So, let's see, if I put a negative number in here, this term will be positive, negative, negative, and of course positive. The constant isn't ever going to change. How many changes do we have for the negative roots? 2. So of course we write 2 or 0. And then what about for my imaginaries? Keep in mind, this problem has how many roots? 10. We have no positives and 2 negatives. That would be 8. Or none and none, that would be 10. So, in terms of thinking about the graph of this thing, the most times that it could hit the x-axis would be how many? No, not this one. The most times it can hit the x-axis is 2. Remember, imaginary roots aren't graphable. They cause bumps and lumps in the curve, but you're not going to hit the x-axis. The most you could hit would be 2. Potentially, what about this graph? It might not hit the x-axis at all, right? We'd have to graph it or do something else to make that determination.
You said like this was a tool, right? Like
A tool.
Are there ever going to be any questions where it's like solve the problem using the Carday's rules
No.
of signs?
The question will be, you are free. So when it says find the roots, like it did on the quiz, you are free to do this if you think it might help you. There will be a question that says, here it is, what is the nature of the solution? So I want to test to make sure you know how to use the rule, but you will never have to use the rule in the course of working another problem.
Okay.
Does that answer your question? Yeah. Okay. So I'm going to expect you to be able to fill these numbers in, but then we'll move on to the next problem. I'm not going to ask you to use those numbers. You are free to do that if you choose. Okay, so now we've got all the quizzes turned in. Whoop, one more question. Yep. Yes, there are 10 altogether. If none of them are positive and 2 of them are negative, how many have to be imaginary? There are 10 altogether. You have none and 2. How many have to be imaginary? 8. You're either real or imaginary. There are no other options. So if 2 are real, then there have to be 8 imaginary. If none are real, then there have to be all 10 imaginary.
Are you basing this
Yes. 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 Because they have to add up to 10. All right, that quiz took way too long. Way too long. So what on the quiz bothered us?
The first one, the cookie one.
Okay.
The bonus.
All right. Okay. We're not going to waste time on bonuses from now on. If that's what you were working on, I'll have to pay more attention to that. Because we're not. That quiz should have taken 15 minutes. Okay. Yes. That everything on there was super simple. Should have taken 15 minutes. Let's go. So. That tells us one thing. You don't know this well enough yet. So, but it's okay. You got a week before the test. But the test's going to be a whole lot longer than that quiz. Okay. So we need to make sure we're ready. So let's talk about the cookie problem. I don't remember the specifics, but I'm sure you can remind me. We have, right now, she is selling 120 cookies for 50 cents each, right?
Yes.
But she's going to make some changes. So what are the changes? Well, she's going to raise her price. That's going to go up. And every time she raises her price, the number of cookies she sells will go down. That's basic econ, folks. Price goes up, sales go down, okay? Price goes down, sales go up. So one of these is gonna go down and one is gonna go up every time. Now, the price is going up in increments, and the increments were 5 cents. So the price is gonna go up in increments of 5 cents. The number of cookies sold is going to go down in increments of 4. So this equation represents her new revenue. So we wanted to maximize that, so we're gonna boil this out.
Yeah, that's why you got it.
And I hope I foiled that right. And since we want to maximize, we got a parabola opening down. We can find the vertex, negative b over 2a. By the way, if you use the calculator to find the maximum on this, I can't count it wrong because I didn't tell you not to, but on the test you will specifically be told that if it is quadratic, you are to show work. So that means you should, it's easier actually and faster to do negative b over 2a, which is 10. And what does that 10 represent? Is that 10 cookies, $10, 10 what? 10 increments, 10 number of changes. So every change was worth 5 cents. So if she changes 10 times, she's going to raise her price 50 cents on top of the original 50 cents. So the new cost would be $1. Now, the next problem you see isn't going to be cookies, it's going to be something else. But the idea is always the same. The price and the number sold are changing in increments, one going up, one going down. Every problem is going to be structured exactly the same way.
Which is the bonus part?
I don't know. What else caused you problems?
The PRR will be for the bonus.
What?
Like the 7x to the 20x or something like that.
Okay, well, keep in mind that for PRRs, what the hours are don't even really matter. It's just what you start
1 and 2
into.
over 1 and 3.
So, I don't know, so if this is the problem and we're doing PRRs, factors of 2 over factors of 7. So that would be 2 over 1 and 1 over 1. So 2 and 1. And then 2 over 7 and 1 over 7. I don't get what's hard about that.
It was this far.
What difference does it make? I mean, seriously.
For the root ones, you just put where it was like, where the root is 7, 0, and it's like 3, 0. You just put y equals, and you factor those out.
You have not been dismissed. Sit down. There's a question being asked.
When they give you the roots, and like, what's the equation? When they ask what the equation
Yes, you have to write the factors. So if you know the roots are 3 and 5, then it's x minus 3, x minus 5.
Okay.
And then foil it together. Okay, now, this, we haven't had a conversation yet, you and I, this year, but we're gonna have it right now. This attitude that we pack up and we run out of this room as fast as we can, even when math is still going on, sends me a very strong message. What message does it send me?
We don't want to.
Okay, I know you don't want to be here. I mean, I get that. But it sends me a message that maybe you don't need to review. So maybe instead of building in 2 extra review days, maybe I only build in 1. I am behind where I should be based on last year. So maybe I just cut out a review day. That's the message you're sending me. So if that's not the message you want to send me, then you change your behavior. Because I'm going to read you, and I'm going to accommodate. I don't need 2 days of review. I'm gonna get down on this test. The review's for you. You don't want it, fine, we'll move on. Got it? All right.
Slow down over there. Slow down over there. I'm not looking all the way around.
You say you don't need the extra connection.
Sam, what did you get for the first problem? Where it was like, what's the equation? Yes, I did.
God bless you. Have a good weekend. Bye. Be good. Homework due Monday. Do not forget. Do not forget. God bless you. Have a good weekend. Have a good weekend. Thanks for being here on time. Bye. Hope you feel better. Bye, Patty. Have a good weekend. Don't forget you owe me 50 cents. Bye. Have a good weekend. You too. Okay. I don't know if anybody turned this off or not.